In this video, we'll do the integral of 1/2 times the square root of 1 plus 1 over x from 0 to 1. Also, don't forget to subscribe and turn on notifications so you don't miss a video. Okay, we can write this as the integral from 0 to 1 of 1/2 times the square root. Okay, so 1 can be written as x over x. So we can have a common denominator of x, and we can split the square root. So we have the square root of x plus 1 all over the square root of x. Okay, good. Now we can do a trig substitution. Let's let x be tangent squared theta. So dx will be 2 tangent theta times secant squared theta, because that's the derivative of the inside. So this would be 2 tangent theta to the first power times the derivative of tangent theta, which is secant squared theta. Okay. Now why do we pick x equals tangent squared theta? Because we know 1 plus tangent squared theta is secant squared theta. Under the square root, it turns to secant theta with this, and things will simplify. So this will be the integral. We're not going to worry about the bounds yet. So we have 1/2, and on the top we have, so the square root of secant squared theta, we can just use that as secant theta. Okay, all over square root of x. Square root of x will be tangent theta. Okay, dx will be 2 tangent theta times secant squared theta, d theta. And look where it happens. 2 over 2 will cancel. Tangent theta over tangent theta will cancel, leaving us with secant cubed theta. Okay. So we can simplify this a lot. So this would just be the integral of secant cubed theta. Now what are the bounds in terms of theta? When x equals 0, we have 0 equals tangent squared theta. So that means that tangent theta equals 0. Theta will be 0 in this case. That's a base angle. So starting at 0, so when x equals 1, we have tangent squared theta equals 1. Tangent theta, take the positive branch, so that would be tangent theta equals 1, works. So that means that theta, so tangent of what equals 1? Theta has to be pi over 4, because this is when sine equals cosine, so sine over cosine would be 1. Okay, good. So this would be the integral of secant cubed theta from 0 to pi over 4. Okay, good. So let's do the integral without the bounds. So the integral of secant cubed, let's call it y dy. So how do we do this? Okay, now we're going to do the di method. So integration by parts, basically. So we have plus minus and then plus. Okay, we'll just do one. Okay, so we know that the integral of secant squared theta, so this we're going to integrate this, is tangent theta. The integral of secant squared y is tangent y, because the derivative of tangent y is secant squared y. So now on the derivative part, we're going to put secant y, what's remaining, and the derivative of secant y is secant y times tangent y. Okay, so we do this, multiply by this, which is secant y times tangent y, okay? And now this, and multiplied together, is an integral. So we have minus the integral of secant y times tangent squared of y, and then dy. Okay, good. What do we know about tangent squared of y? Trig identity, this is secant squared y minus 1. Okay. So now we can split this up. So we have the integral of secant cubed y dy is secant y tangent y. Okay, so we're going to have minus the integral. So this part is minus plus. So that'll just be secant cubed y. Okay, dy. We can close that off. And then the next part is the minus 1. So minus 1 times minus secant y is just plus secant y. So plus the integral of secant y dy. Okay, good. So what do we notice about this and this? We can just, they're the same thing, so we can just add on both sides, add this integral on both sides. So I is the integral of secant cubed y, so we get 2 times the integral of secant cubed y dy is secant y tangent y plus the integral of secant y. Now this is a pretty common integral, and the answer to this is ln of absolute value of secant y plus tangent y. Now how do you do this? And then plus c, but we're not going to worry about that because we're going to plug in bounds. Okay, how do we do this? So the integral of secant y, so the fastest way of getting this is you can multiply top and bottom by secant y plus tangent y plus tangent y, and this is multiplying by 1, so it doesn't change anything. Okay, so if I let u equal secant y plus tangent y, now on the top, what are you going to get? So you're going to get secant squared y plus secant y tangent y. Okay, so du will be the derivative of secant y with respect to y is secant y tangent y. Then we're going to use parentheses because we have to add stuff and then multiply it by dy. Okay, the derivative of tangent y with respect to y is secant squared y. That is exactly what we have here. So this and this is our du, and then this is u. So the integral of 1 over u is ln absolute value of that u, which is secant y plus tangent y. Okay, so we have ln absolute value of secant y plus tangent of y. Okay, but that's 2 times this integral. So how do we get the original integral? We have to divide by 2, obviously. So the integral of secant cubed y dy is secant y tangent y plus ln absolute value of secant y plus tangent y all over 2. Okay. So what's funny about this is secant y tangent y is the derivative of secant y, and this is the integral of secant y. So that's a fun fact. Okay. Now we're going to plug in from 0 to pi over 4, right? Because that's what we have here. With respect, this is with respect to theta, but this is with respect to x, y. It's the same thing. Okay, so we have from 0 to pi over 4. Okay. So let's plug in 0 first. Okay, so secant 0 is 1 over cosine 0, which is 1. We know that tangent of 0, that's defined to be 0. Okay, so we're going to have, so let's look at the top only. So we're going to have secant 0, which is 1 times 0, plus ln of 1 plus 0. This is 0. ln of 1 is actually 0. So the bottom term we're going to ignore. So we're just going to plug in at pi over 4. So secant of pi over 4 is 1 over cosine of pi over 4, which is 1 over cosine of pi over 4. You remember it's square root of 2 over 2, but that can be written as 1 over square root of 2. Now take the reciprocal, and that would be just the square root of 2. Okay, tangent of pi over 4 is 1, because that's sine of pi over 4 over cosine of pi over 4, which is the same. Okay, so we're just going to plug in what we know. So secant of pi over 4 is 1. So we're going to have the square root of 2 times 1 plus ln of the square root of 2 plus 1. And this is positive, so we can get rid of the absolute value all over 2. So just simplifying it a little bit, this would be the square root of 2 plus ln of square root of 2 plus 1, and now multiply by 1/2. And that is the end of the video. Hope you liked it, and thanks for watching.